Hello everyone, my name is Mehdi Zahid. I am a registered architect with the Alberta Association of Architects and an educator at NATE, the Northern Alberta Institute of Technology, based in Edmonton, Alberta. I'm the chair for the Cabin Leadership Forum Alberta Hub. Our team is a group of volunteers who coordinate events that empower industry professionals to radically reduce embodied carbon from buildings and infrastructure. For more information, please see our website at www.clfalberta.com. The recording presented here is our first online event held on December 10th, 2020. The presenter is Mr. Anthony Pack, the principal at Priopta and the Regional Hub Director for the Cabin Leadership Forum. Please do not hesitate to contact us if you have any questions via our website. Thanks for watching.
Okay, I think it's been a minute. We gotta get started, so we'll just let people keep coming in and logging in as it happens. But welcome everybody. Thank you so much for becoming and joining us for our first Carbon Leadership Forum of Alberta event. So we're very excited. Of course, this year came with a bunch of challenges, but I think the opportunity for us to launch virtually definitely worked out. So we're happy to have quite the turnout. So thank you very much. And I did just want to quickly point out our website. Unfortunately, Mehdi, I can't share it, but please go to clfalberta.com, and that's where you can find all your information on joining our mailing list, our next events, videos, information on embodied carbon and what we're trying to do, and the information and education we're trying to bring to the Alberta Hub and have this global organization, but from a little bit more of a Alberta perspective as well. So that's what we're hoping to do. You can see there's where we would sign up right at the very beginning. And we have our mission and our kind of background. And also note that there is the online community as well. If you'd like general updates, there's lots of information on the forum, on the online forum that covers all regions and all types of information. There's our event information, and you can see that we're all here today already. We did sneak in some past regional events from Vancouver that we think will be really helpful for anyone wanting to know and start watching some videos on carbon. And then City of Vancouver embodied carbon policy, something very interesting that we want to keep our eye on and potentially see what we can grab and compare to Alberta. And then I believe, oh, maybe we'll get pictures. I don't think we're going to screenshot anything today, but eventually we'll have in-person events, hopefully. And then this is the CLF Alberta team. So we have Mehdi, our chair from NATE, and he's online helping us today. And myself, Kristen, I'm from EcoAML. I'm in charge of the North. And then we have Ignacio in charge of the South. And Ali is online as well, and he's kindly helped put together this beautiful website and all our information. So please check us out. We are new and we are budding and we're trying to figure it all out, but we really want to make sure that we're giving information that would be most pertinent to you and all the attendees. So if you don't mind, we will take a quick poll just to start things right off. And we just want to see where you guys are coming from and try and get more information. We started just being Alberta based. We didn't really know if there'd be a regional distinction yet, but eventually there might be. So maybe it'll be CLF Edmonton and Calgary, but we just wanted to gauge people's interests. So there we go. I submitted my answers. So thank you very much for doing that. In the meantime, I will introduce our speaker today. This is I think a really great way to start out. We have Embodied Carbon 101. So that's with Mr. Anthony Pack, and he's coming to us out of Vancouver. So thank you very much for joining us, Anthony. Anthony is a principal at Priopta. So they are out of, as I mentioned, Vancouver, and they do detailed life cycle assessment and really look at the data and extreme knowledge behind reducing embodied carbon. And he's the founder of the CLF in Vancouver and is actually our regional hub director as well. So very passionate about carbon, and he's really showed that. I was lucky enough to hear him speak. So I think we're all in for a really, really great educational experience coming up. I think that's it for now, if I can just pass it off to Anthony. So thank you.
Sure. Thank you so much. Thanks for the introduction. And yeah, hi everyone. Thank you for joining this. It's great to see such an amazing showing for the first CLF Alberta event. I remember when we first started CLF Vancouver, we just had, I don't know, less than like 20 people in a room. it was a like kind of humble beginnings initially, but the word spread fairly quickly. And so it's great to see that CLF Alberta is off to a great start. Let me just see if, for some reason, the host has disabled participant screen sharing. I'm wondering if, Mehdi, can you do something about that? Sorry, we should have probably tested this out beforehand. It may be in the security settings or something. Mehdi, if you can.
That's exactly where it is.
Yeah. Okay, here we go. I think I got it now. All right. Can everyone see my screen? Yeah, good. Awesome. Yes. Amazing. Okay, so I'm just going to jump straight into it. We got an hour. I typically have a very information-packed presentation, but I'll try to do it quickly so that we have a little bit of time for Q&A at the end. Yeah, I'll also mention that these slides are also available on my company website, priopta.com. So if you scroll to the bottom, you'll see the full slide deck. And there's a lot of information in here. Part of this whole, this slide deck is sort of the best available information that I've come across relating to embodied carbon. And so you'll see on many of the slides, at the bottom of the slide, there's links to resources. So you can kind of use this as sort of a launching point to many different research reports or resources, et cetera, on that. So you can find that at the bottom of the website if you want. So today I'm going to be talking about embodied carbon, which I oftentimes refer to as the blind spot of the building industry. Because it's historically been something that we've neglected. We have a lot of focus on energy efficiency and reducing operational carbon emissions in buildings. But when it comes to materials, we haven't had as much focus. So I'll share a little bit about myself first. As Kristen mentioned, I'm the founder of the CLF Vancouver chapter. We started, I think, in April of last year. And obviously back then we were able to do in-person events. This is actually a picture of like our very first event where we had like about 20 people and we were kind of doing workshopping. And then since then we were like hosting a bunch of events at local architecture firms or structural engineering firms. And then now we've kind of transitioned online. But given that we're doing presentations online, I encourage you to sign up for the CLF Alberta mailing list, but also if you're interested in seeing like the events that we do out of Vancouver, you can also sign up for the mailing list there. There are now over 25 cities around the world that have started up these CLF local hubs. And so I'm one of the 3 regional hub directors. So I'm supporting all the hubs that are in Western North America, which obviously includes Alberta. Sorry, this should say Alberta instead of Calgary. And a bunch of cities along the West Coast of the US, and also Australia, New Zealand, and Hong Kong. So the Asia Pacific region as well. So if you see your city, I mean, if you're outside of Alberta and you would like to participate in another local hub, or you see your local hub there, feel free to kind of, I encourage you to reach out to them. And if you don't see your hub on there and you want to start up a chapter, reach out to me. I can help you get set up on that front. I think these local hubs are really a great way of spreading and building awareness on this topic, which is new for a lot of people in the industry. And also, as was mentioned earlier, there's the online discussion. So when you sign up to the Carbon Leadership Forum, which is like the larger organization beyond kind of the local hub level, you can, there's an option to to join this online community where you can access a lot of resources, ask questions. There's a lot of active discussions that are happening on there through that forum. So I encourage you to join that as well. And just a quick note about our company, Priopta, which is a consulting company that's specifically focused on whole building lifecycle assessments. So we do LCAs for mainly new construction projects. We can do everything from kind of well, actually, I'll just leave it at that for now. And sometimes we also do some embodied carbon research projects as well, some special research projects relating to this topic. And our mission is to drive radical reductions in embodied carbon globally. So now I'm going to get into the presentation. What do we mean when we're talking about embodied carbon? It really actually refers to the environmental impacts of all the construction materials in a building. Actually, I'm missing one of the slides. So we're looking at all the materials that go into a building, things like concrete, steel, wood, and glass, insulation. And the life cycle in life cycle assessments, it refers to the life cycle of these materials. So everything from resource extraction, transportation, processing, manufacturing, all the way to end of life, deconstruction. Are you recycling it? Are you reusing it? There's emissions along every step of this life cycle stage. And so these pictures kind of illustrate some of those impacts, right? So what's the impact of mining these resources? What's the impact of manufacturing and processing, et cetera? And these are oftentimes hidden, right? They're not things that we observe readily when we're looking at, let's say, a piece of concrete, but there is a whole history to it. And how do we account for that? Now, as I mentioned earlier, the building sector is actually responsible for about 39 to 40% of global CO2 emissions. So if you look at the annual emissions each year, about 40% pertains to this building sector. 28% is to operate all the buildings on the planet. So think of every building, what it takes to heat and cool and operate the building. That's 28% of the CO2 emissions. And then think about each year how much new construction is taking place and renovations. And the emissions associated with the embodied carbon emissions associated with all those construction materials for the new builds each year, that's 11% of global CO2 emissions. So this is what I refer to as the blind spot, this 11% slice of the pie. This is what we've historically neglected. We don't typically quantify it on projects, but it is actually extremely significant. And what's interesting as well is that, as we're talking about embodied carbon, we're talking about concrete, steel, aluminum, and a bunch of other materials. The building industry is a big user of these materials. So even just these three materials, concrete, steel, and aluminum, they together make up almost 23% of global CO2 emissions. Now, obviously, the building sector is not the only user of concrete, steel, and aluminum. There's also those materials also go towards infrastructure, go towards like building cars and products and stuff like that. But what's interesting about this is that if we address embodied carbon, we have the potential to affect the supply chains, which then has a ripple effect even beyond the scope of the building sector, right? If we can get lower carbon concrete mixes, that'll impact infrastructure as well as building sector, for example. Sorry, there's probably some sirens that you might hear in the background. I'm in downtown Vancouver, so it's kind of hard to mitigate that. Okay, and if we only look at the new construction that's taking place each year, the new construction that's taking place between now and 2050, so over the next 3 decades, we can see that embodied carbon will account for almost 50%, almost half of the emissions associated with that new building stock over the next 3 decades in that time horizon, with operational carbon being the other 51% of the impacts. So it's clearly a really significant source of emissions, but also when we think about in the context, that's also important because you need to consider how much new construction are we projected to build. And at our current rates, the projection is that we're going to double the current building stock by 2060. So in the next 4 decades, think of all the buildings that exist on the planet, all the square footage of buildings. We're going to double that in 4 decades. And so what this graphic shows is how much new construction is projected to take place by 2030, by 2040, and by 2060 across these different regions or countries. And so, the sizes of the circle represent, the various different scales of billions of meters squared of floor area that's going to be built, right? So there's a lot that's being built in North America, obviously a lot in China as well, and especially in the later decades, that's what the lighter shades are, like the lightest shade is 2060. You can see the further development will take place in like places like India and Africa, but North America and Europe still accountable for a very sizable chunk of these emissions. And so we can't hit any of our climate targets if we don't address embodied carbon emissions. So put that in a different context, we're building the equivalent of an entire New York City every month for the next 40 years. So think about all the buildings that exist in New York City, and not just Manhattan, that's all 5 boroughs, something like 5.8 billion square feet of floor area. That's how much we're building every month for the next 40 years. And so naturally that you would think we're obviously using a lot of the material supply in the world. So this is actually a snapshot of how we use resources on the planet. This is the total flow globally of by mass, what type of resources we use, like minerals, ores, fossil fuels, and biomass, and how that flows to our end uses. So for example, the housing sector accounts for about 44% of the global material use. So almost half of global material use goes towards our buildings. And you've heard a lot of talk about circular economy. As a planet, we are about 8.6% circular, meaning 8.6% of the massive resources comes out at the end of the lifespan and then gets cycled back, either recycled or reused in our society. And so that's a fairly small percentage, and it's actually decreasing because the amount of demand that we have for new construction and new products, and it's outstripping it. So like this percentage is actually decreasing every year right now at current rates. So how does this figure into the global climate targets? If we're going to hit the 1.5 degree scenario target, which a lot of scientists say we should be aiming for from a climate change perspective, that means that this year we need to peak global emissions. By 2030, in 10 years, we need to halve global CO2 emissions. And then by 2050, in 3 decades, we need to get to 0 emissions. And then we need to go negative, which is extremely significant, right? And to give you a sense of the percentage reduction we need each year, to hit that 1.5 degree scenario target, that's 7.6% per year. To hit the 2 degree target, that's 2.7% per year. Some early estimates back in April, actually even some of the most recent estimates that I've seen for the emissions reduction this year due to COVID, due to all the shutdowns and like the slowing of the economy, that's about 7 to 8% this year. So this year we're maybe on track for that 1.5 degree target, but think about what we need to do for each successive year. You know, obviously these are not sustainable reductions, they're kind of a temporary reduction. And it's important for Canada as well. You know, when we hear about climate change, sometimes we think it's going to impact other places more than us, but actually Canada is warming at twice the rate as the rest of the world. So whenever you hear these scenario targets, like 1.5 degree scenario for the global, that's a global average. That means Canada is probably averaging 3 degrees because we're warming at twice the rate as the rest of the world. And that's an annual average. So think about what the monthly variations might be, the peaks and troughs of that. It can be quite significant. So there's big implications for our country. And then especially when you get further into the north, like the northern Canada region, it's warming at 3 times the rest of the global rate. So that's kind of the global context for why we need to address embodied carbon. Now, what does it actually look like on an individual building level? And the metric I want to use is kilograms of CO2 equivalent per meter squared of floor area. And we can use that metric for operational carbon emissions, but also for embodied carbon as well. So if you look at the lifespan of a typical building, let's say hypothetically it lasts for 60 years. These yellow bars, it shows the operational carbon emissions from heating and cooling and operating the building each year. So imagine this is like the emissions that we have historically we already do account for, which in the design phase, we're calculating that through energy modeling, for example. Similarly, the red emissions is the embodied carbon. So upfront, when you build the building before it's occupied, there's a big pulse of emissions that's associated with all the materials that go into, you know, the structure and envelope of the building. But then throughout the lifespan, let's say certain components only last 20 years, for example, we account for replacements, we account for maintenance as well. And then also any emissions associated at the end of life, we also account for those emissions. And to quantify the embodied carbon, that's where we use life cycle assessment. So LCA is kind of analogous to energy modeling. You need to add these 2 scopes of emissions to get the holistic picture of like the total emissions for your building. And when we're looking at life cycle assessment, you know, you hear a lot of talk about embodied carbon, but in an LCA, we actually look at multiple environmental impact categories, not just carbon emissions. And so we look at global warming potential, GWP, which is oftentimes referred to as embodied carbon. So that's the main figure that a lot of people pay attention to. But we also look at things like acidification potential, eutrophication potential, smog formation, depletion of non-renewable energy, and ozone depletion. So this is when we do an LCA, we quantify these other environmental impacts as well. I mentioned earlier about all those life cycle stages. So there's formal definitions for what each of these life cycle stages are. So broadly speaking, module A is the upfront carbon. So that's all the emissions before the building gets occupied. That's everything from raw material supply. So that's like the harvesting of timber, the mining of ores, then the transportation to the manufacturing facility or processing facility, and then transportation from there to the construction site and any emissions associated with the construction and installation. So that's A1 to A5. And then the B stage is during the use phase. So if there's any emissions associated with, for example, refurbishments and replacements, that's what we account for there. And then at end of life, anything from demolition, deconstruction, transportation, waste processing, disposal. Sometimes you'll also see LCA results that mention module D, which accounts for reuse and recovery and recycling. Those are benefits that are beyond the boundary of like your individual building. So if, for example, you want to account for reuse for the next building or recycling benefits, or let's say you're incinerating some material and you're offsetting energy that's used or fossil fuel energy, for example, how do you account for those benefits? That's in module D, but we typically report that separately as additional information. And if you combine the LCA results on the material side, plus the operational carbon, that's V6, that's the energy modeling results, for example, or your utility bills, those two combined together, it gives you your whole life carbon. Now, historically, the thinking has been embodied carbon is, maybe not as significant. Embodied carbon in this chart is represented by the green portion of this donut chart, and then the gray portion is the operational carbon. So, historically, the thinking has been operational carbon is way more important. Maybe embodied carbon is like 10 or 20%. Let's just not worry about it. Let's just focus on the operational piece. That's the big piece. But what we're seeing is that as we're designing more energy efficient buildings, and we're cleaning up our electricity grids, for example, the embodied carbon portion becomes a bigger slice of a smaller pie. And so that's just one way of thinking about it, is anytime you hear about these percentage splits between operational carbon and embodied carbon, it's very context specific. It depends a lot on what the operational carbon is in the where that building is built, what the carbon intensity of the grid is, for example. And also, on the embodied carbon side, there can be big ranges as well. So let's put some numbers to it. In BC, we have a fairly clean electricity supply. It's mostly hydro. So from a carbon intensity standpoint, it's very, very low. And so if we electrify our buildings in BC, we can actually have really low operational carbon emissions. And so you may have heard of the BC Energy Step Code. This is, as you get to higher steps, we get more energy efficient buildings. But this was a study done by Integral Group where they looked at part 3 buildings, so like larger buildings beyond 600 meters squared. For these buildings, they actually looked at natural gas systems versus electric systems. And you can see our electric systems are really low. It can be as low as 1 to 2 kilograms of CO2 per meter squared per year. And we have various different limits within the city of Vancouver, for example, in our rezoning requirements that limit the operational carbon greenhouse gas intensity. So those are really low numbers, right? And let's say a typical building in Vancouver maybe is more like in the range of 20 kilograms of CO2 per meter squared. So something that's maybe uses natural gas and not particularly energy efficient, that might be in the 20 range. But we can see there's big variations. Let's say a baseline building in Calgary could potentially be like 71 kilograms of CO2 per meter squared per year. So every year to operate the building, let's say something in that range, right? In Calgary or in Alberta, there's a lot of natural gas heating. Also, the electricity grid is much more carbon intensive. There's a lot more coal use and natural gas use. So that changes the picture quite a bit. Plus, the climate is also much colder there. So that also affects things. So we can see, even on the operational side, it can vary a lot. I've seen numbers higher than 100 kilograms of CO2 per meter squared per year. And then it can be as low as like 1, right? Like in BC. So just to give you a sense of how big that range can be. And as I mentioned, the electricity grid carbon intensity is a big factor of that. So let's say Alberta, it's at around the average carbon intensity of the grid is around 800 grams of CO2 per kilowatt hour. Whereas in BC, it's like 10 or 12 grams. So big variation there. And we actually see this across the world. It's not just within Canada that we have such big discrepancies. Even in the US, I mapped out all 50 states, the carbon intensity of every state. You can see is in the blue bars, and then the red bars show you the actual amount of electricity generation in that state. So for example, Texas is a big state, so there's a lot of electricity generation there. And then I show you the grid mix. So the proportion of like renewables versus fossil fuels, for example. So you can look at this graph later on, download the slides. And then similarly, around the world, these are national averages. You can see, Canada national average is like around 150. But again, there's a lot of spread between different provinces. It can be as high as 800. It could be as low as 12. And then similarly, you see that across Europe, across Asia, the big ranges. And so the electricity carbon intensity has a big impact on the operational carbon intensity of a building, but it actually also affects embodied carbon as well. Because if you think about the production processes for many different materials, some of them are very electricity driven. And so then the carbon intensity of the electricity grid will affect that a lot. So what's the range of embodied carbon emissions? This was a study done by the Carbon Leadership Forum back in 2017. They gathered 1,000 whole building life cycle assessments from around the world. And the general range that they see is, some studies are below 100 kilograms of CO2 per meter squared. That's the embodied carbon. And it could be as high as 1,000. And with many of them in the, let's say the 200 to 600 range. Click Lca, which is a Lca software tool, they've also kind of created their own benchmarks from projects that have used their software tool. And their benchmarks are more European focused. A lot of the projects are from Europe. But again, they kind of create these letter grade rating systems and show you the ranges in embodied carbon. So for example, if you're above 800, that's like really bad. If it's below 200, it's considered relatively good for different building types like office or apartments. So that gives you a general sense. But these benchmarks typically only focus on the building structure and the envelope. So there's still elements that aren't being accounted for, things like mechanical systems or refrigerant leaks, things like interior if you're in a commercial office building, for example, the frequent replacements of these tenant improvements and the interiors and the fit outs, that oftentimes doesn't get accounted for. So if you tally all of that up, the numbers probably add up to even higher than what's being shown here. So next, I'm going to talk a bit about policies and standards. So what's the imperative for actually addressing embodied carbon? We see that around the world, whether it's voluntary green building rating systems or regulations, there's many systems that are actually addressing embodied carbon in some form. Some just require disclosure, reporting of the emissions. Some actually have reduction requirements. Some of the ones that are particularly relevant in North America, I'll talk about it soon, but what I see is generally from a policy perspective, or even in these voluntary rating systems like LEED, there's kind of two different scales at which they apply when it comes to embodied carbon. One is like kind of the whole building level. So looking at your whole project, what's the total emissions and how do you reduce it? Can you reduce by a certain percentage relative to some baseline? So there's a whole series of, whether they're credits within LEED or requirements like the City of Vancouver's policy, that's whole building level scale. And then there's a range of other policies that kind of address things at an individual material or product specific level. And how we quantify those emissions is through what's called environmental product declarations. And if you're not familiar with that, EPDs are basically like food nutrition labels applied to products. So in the same way as a food nutrition label might say, what's the health impacts associated with, each serving size of a food group or food product, let's say, EPDs report the environmental impacts per unit of a product. So basically what's happening is, let's say I'm a concrete manufacturer or supplier. I want to do a life cycle assessment of my whole supply chain and my specific concrete mix. You can do an LCA, they can and it's third party verified. And then they produce this document, which is published. And then you can actually see what the environmental impact, for example, the carbon emissions per meter cubed of concrete for them. So that's what an EPD is. It's kind of like a reporting of the emissions associated with individual products. And so there's a suite of policies that kind of tackle things at that level. For example, Marin County has a low carbon concrete code. There's a Buy Clean California policy as well that addresses a few categories of materials in California. There's similar efforts being pushed for in Washington, Buy Clean Washington, and even in the government of Canada, I think they're starting to think about procurement requirements as well at individual material level. So here's a kind of in one slide, I'm trying to summarize some of the key ones that I think are relevant in Canada or that you may come across. So I'll get to Vancouver later, but in terms of the rating systems, if you're using something like LEED in version 4.1, you can get up to 5 LEED points for one of the credits that are focused on life cycle assessments. And so, for example, depending on how much you reduce, like if you get 1 LEED point just for disclosure, just for doing the LCA and reporting the emissions on your embodied carbon emissions, and then you can get 2 points for 5% reduction, 3 points for 10% reduction, 4 points for 20% reduction. And in some regions, they also get an additional regional priority point as well. So up to 5 points for that, which can be actually a big part of a LEED strategy for a project. If you're going for the CAGBC's zero carbon building standard, you need to do the LCA of your building and offset it. And there's also an impact and innovation strategy credit at the end, which is one of the possible paths to pursue, where you have to achieve a 20% reduction in embodied carbon. And then if you're looking at the International Living Futures Institute, they have 2 standards. One is the zero carbon certification, which requires a 10% reduction relative to a baseline on a building level and a max cap of 500 kilograms of CO2 per meter squared. In the Living Building Challenge under the energy pedal, they require 20% reduction in embodied carbon and offsetting the remaining emissions. So those are kind of voluntary standards, right? Then there's actual regulations. So for example, in the city of Vancouver, under our rezoning policy since 2017, many of the projects that go through rezoning, which accounts for a little over half of the new construction in Vancouver, many of them do need to do a life cycle assessment. And what they did was they just reported the emissions at that stage. And they needed to report it during the rezoning application, which is schematic design. Then they needed to update it during building permit, and then once more at occupancy. That will soon be revised next year. So you may have heard the City of Vancouver also recently approved their Climate Emergency Action Plan. And one of the big action items on there was they have a target for embodied carbon, which is by 2030, the embodied emissions for all new buildings and construction projects need to be reduced by 40% relative to a 2018 baseline. And that is, in my opinion, probably the most ambitious embodied carbon policy or target in North America, and it's right up there globally. And so they recently just released kind of the roadmap for how they're going to get there. And so the rezoning policy next year will be updated, where they will require projects to reduce at least 10%. It may potentially even be more. The final number hasn't been decided yet. But yeah, they will actually require a reduction in embodied carbon. And eventually in 5 years, that'll make its way into the actual building code. So then all projects need to do that. This is kind of the roadmap for what it looks like in Vancouver. I won't get into the details, but if you want to read through it, there's a link at the bottom, which is really helpful for anybody that's interested in policy around embodied carbon. And actually another resource is, I do actually think regulation and policy is one of the biggest drivers for addressing embodied carbon. And so, if you are working at a municipal government or at a provincial government or at the federal level, I highly encourage you to actually look at this, look at embodied carbon policies. It's a big source of potential reductions. And if you have connections to people that work in these various levels of government, you can send them this document. I think this document is actually really amazing. It was put together by the Carbon Neutral Cities Alliance and Click Lca and Architecture 2030. What they've done is that they've evaluated 52 different embodied carbon policies, and they actually have sample policy language. And where relevant, they also cite different cities around the world that have applied these types of policies. And they affect, there's policies at various different levels, at the zoning level, building regulation level, procurement, infrastructure, waste and circularity, financial policies, or to municipal buildings. So there's a whole suite of kind of potential policies that may be relevant and can be adapted for each city. So I highly encourage you to go to embodiedcarbonpolicies.com, download it, check it out, or share this with any government officials that you know of that may be interested in this. Okay, now I'm going to talk a bit about Lca Software Tools, which is basically how we quantify these embodied carbon emissions. And there's three main ones that are typically used in the industry, at least in North America. One is Athena, impact estimator for buildings. It's a free tool. You can download it. It's Windows desktop software, and it's great for early design. Let's say you just have PDF drawings. You do some simple area takeoffs. You can kind of input those takeoffs into this tool and build up different assemblies, different wall assemblies, different floor assemblies, and do a whole building LCA that way. And especially at the early design stage, if you're trying to compare between different design options, I think this is actually a really great tool, and it's been an invaluable resource, especially given that it's free as well, freely available. And it has mostly industry average data. So it doesn't really have manufacturer specific EPD data, but they do have kind of industry averages for example, for concrete or wood. Next, we have Tally, which is a Revit plugin. So if you have Revit, like a 3D BIM model of your project, this can be a helpful tool. So because it's a Revit plugin, it's useful in that you can then map directly, the different elements within your Revit model to the big database of embodied carbon emissions related to various different materials in Tally's database. The downside of this is that because it is only a Revit plugin, if you don't have a Revit model, then you can't do an LCA for your project. Or at the earlier stages, if you don't have the Revit model yet, that also limits your ability to do an LCA. And if you're trying to compare between different assemblies, for example, you'd actually have to model it in Revit in order to be able to map it and produce a result. So it's a bit more challenging in that sense, but it's potentially more accurate, especially at the later stages, because you have a more detailed bill of materials, for example. And Athena does not have a Revit integration. However, they do have a spreadsheet import process. And then finally, there's Click Lca. And I should mention Tally is a paid license. I think it's like $1,000 per year. Plus you need the Revit license as well. And then Click Lca kind of covers the broad range of stuff. You can import data through spreadsheets. You can use BIM models. It has both industry average data and manufacturer specific EPD data. So it's probably the biggest database of materials out there. And they have various different levels of licenses as well. But it is paid. And at the top tier, it's something like we pay $4,000 a year for our license. So I know this is probably a bit steep for some people, but it is a fairly capable tool as well. So this is a quick table of comparison. I'm not going to go into the details of this, but if you want to read up on this and the comparisons, I could compare these three software tools in various different metrics, including like the data source and like how easy it is to compare different design options and whatnot. This is kind of stemming from a report that I wrote for the National Research Council, so you can get a link there to see deeper into that. And then you may have heard of EC3, which stands for Embodied Carbon and Construction Calculator. It's a free open source database of all the publicly available EPDs. So they have both industry average and manufacturer specific EPD data, somewhat similar to Click Lca as well. However, this is not a whole building LCA tool in and of itself. So this, for one thing, it only quantifies carbon emissions. It doesn't do the other environmental impact categories. And it's really meant more to inform like tendering stage decisions where you're comparing, for example, between different concrete mixes from different suppliers. So yeah, this is a tool that could be used. They also have an integration with Tally. So maybe you can use Tally, which has mostly industry average data at the early stages. And then at the later stage in the design process, when you're selecting between different suppliers, you could use something like EC3. This is an example of what a finished LCA study could look like. So this is a graph that we've done on one of our previous projects on office buildings. So the whole point of doing an LCA is to be able to figure out where the hot spots are, like where are the areas where the biggest amount of emissions take place, whether it's by building element, like how much is coming from the floors, the walls, the foundation, et cetera. And then what's the breakdown by materials as well. So where, is it mostly coming from the concrete or from the rebar or et cetera. And, as you tweak it, make different selections and whatnot, your LCA basically helps you get a better understanding for where the greatest sources of emissions and potential reductions can come from. So this is just a video of like, working with a BIM model can be really helpful, but it also requires a lot of cleaning up sometimes. And, depending on the quality of the Revit model, it sounds good in principle, but it can actually be more complex than you realize to actually like accurately account for all the quantities. And some things may or may not be reflected in your Revit model. So it's something to watch out for. Okay, so that's how you calculate it. Now I'm going to dig into how do we reduce emissions, and I'm going to go through material by material, a lot of the key material categories where we have potential to reduce emissions. Before digging into each of the individual materials, I encourage you to check out this document. This is from the Carbon Leadership Forum. It looks at how do we integrate LCA into the design process. So what happens at the schematic design? What are the types of questions you should be asking on the structural side, on the envelope side? And then what are the considerations you should look at during, let's say, design development or construction documents and during the tendering of the bidding phase and then during actual construction. So yeah, I just think this is a pretty well outlined like roadmap. So that's a great resource. This was also a study done by Thornton Tomasetti, which is a structural engineering firm, looking at just different structural frame options. So you probably heard a lot of comparisons between, let's say, concrete and steel structures and wood structures. So, you know, across their database of all their previous projects, this is kind of like, I think the averages that they've seen for some of the structural frames that they had. So this is in kilograms of CO2 per meter squared. So for example, like the timber structural frames are generally lower emissions. And then, you know, concrete, typical concrete reinforced is like higher. And then the hybrid ones are a little bit in between. But obviously this will depend a lot on the specifics of your project. So, you know, take this with a grain of salt. You actually need to do the analysis on your actual project. But this gives you some sense. And this is looking at just the structural frame. So not looking at, I believe this doesn't account for things like the envelope or the interiors or the MEP systems. So these are all the key categories I'm going to be going into. So let's start off with concrete. Concrete is the most emission intensive portion of concrete comes from cement. So cement is kind of the binding or the glue, so to speak, of concrete. And it makes up, let's say, 10, 11% of the concrete mix, but it accounts for 80 to 90% of the overall carbon emissions of a concrete mix. So anything that you can do to reduce the amount of cement content in concrete can have a pretty sort of like a correlating effect to reducing emissions of your concrete mix overall. So what are some of the key strategies? One low-hanging fruit is to use Portland limestone cement instead of regular Portland cement. And so essentially they're adding a bit more limestone, reducing a little bit of the cement content, and that can lead to roughly a 10% reduction in embodied carbon. Then you can look at things like supplementary cementatious materials. So things like fly ash and slag, which can then displace a little bit of the cement that's used. So roughly every 10% increase in SCM content can lead to roughly 7% reduction in embodied carbon. Obviously you have to do the actual calculations, but this is just based on some of my high level kind of rule of thumb analysis. And you want to go for performance-based specifications, avoid the prescriptive specifications. So sometimes on projects, you might have prescriptive specifications like you need to have a certain minimum cement content or a maximum water to cement ratio or maximum SCM content. And so these things can sometimes prevent a ready mix supplier from reducing the emissions of their concrete mix that they're delivering. You can use less concrete in your slabs, for example. So explore options like hollow core or waffle slabs or bubble deck. So basically it's just reducing the amount of concrete in there. Sometimes post-tension slabs, which reduce the thickness of the slabs by using post-tension tendons, that can potentially reduce emissions as well. So those are a few strategies that you can apply relating to concrete. So as an example, this is looking at the industry average data from the Canadian Ready Mix Concrete Association. So for 35 MPa concrete, if you compare it relative to the benchmark, which assumes 10% supplementary cementatious materials content, and you look at these various different options. So GU is regular Portland cement, GUL is Portland limestone cement, and then you have the various different percentages of SCM content. At the highest level, let's say use Portland limestone cement and 35 to 50% SCM content, you can get about 35 to 40% reduction per meter cubed of concrete for the same strength. So there is potential to reduce a lot of emissions, and you need to optimize this for each element of the building. Like how high can you go on the SCM content for your foundation versus your above grade slabs versus your columns. So that's something that's a conversation to have with your structural engineers and your ready mix suppliers. Next up is steel. So there's two main ways of making steel. there's basic oxygen furnace, which is much more emission intensive. And then there's electric arc furnace, which is lower emissions, maybe roughly half the emissions. So in the basic oxygen furnace, it's mostly virgin iron ore, very little recycled content, maybe like 25% or less. And it does account for like 71% of the global steel production. So most of the steel, especially in Asia, is produced using BOF steel mills. And then electric arc furnaces use a lot of recycled content. So typically, let's say 97% recycled content. And because it's an electricity driven process as well, it can really reduce emissions depending on the carbon intensity of the grid. So, if it's produced in a state or in a province where there's very low carbon intensity in their electricity grid mix, that can have a corresponding impact on the carbon intensity of the steel that they produce. So just generally speaking, just try to understand where your steel is coming from, what's the process that it was made in. And if you can, try to find the electric arc furnace steel. Although the caveat here is that we are limited with how much recycled content steel there is, right? So it doesn't necessarily solve the whole problem. We still need to also address how to reduce emissions in basic oxygen furnace steel as well. So there are some new innovations that are coming online, or maybe at the research scale. So I don't know if it's quite at commercial scale yet, but there's a lot of people that are looking at how to reduce emissions of steel. I'm going to jump past this. And then wood, generally speaking, wood, when we do Lca studies, it typically shows that they're lower carbon emissions compared to, let's say, steel or concrete structures. And you'll oftentimes see case studies that compare, wood buildings versus concrete buildings and what the percentage reduction is. It's very case specific. It depends on the building archetype and the specifics of the case study. But also when it comes to wood and biogenic carbon, so carbon relating to biomass, so things like wood or even fast growing materials like hemp, for example, it can be a little bit tricky in terms of how we quantify those emissions. I'm not going to get into the details of that, but sometimes these studies, they account for a negative credit for the storage of the carbon in the wood, for example. So it's important to understand the assumptions of that analysis. Did it account for negative carbon storage, or different Lca software tools have different assumptions around this. I actually did a full presentation just on this topic, which is on our CLF Vancouver website, or sorry, YouTube channel, which you can search up if you're interested in learning more. But it's a pretty complex topic, but generally speaking, when we're doing Lca studies, it does show relatively lower emissions, but we need to ensure that it's coming from sustainable forests, or the forests are sustainably managed. Next thing is aluminum. So aluminum is an extremely energy intensive material. It uses 10 times more energy to produce than steel. And it's an electricity process. So even more so, it matters what the electricity source is when it comes to the aluminum production. What's interesting is actually Canada has the lowest carbon aluminum production in the world. We are the 4th largest producer. And because we use the latest generation of technologies in our aluminum production facilities, but also we have where we produce aluminum, let's say like in BC or in Quebec, there's a lot of hydroelectricity. So the carbon intensity is really low as well. And so generally speaking, we have extremely low carbon intensity aluminum relative to the rest of the world. That said, it still is very high. So it's still a very high emission intensive material because it uses like 10 times more energy to produce, right? And there's not enough recycled aluminum to go around to meet global demand. So the primary aluminum production, similar to steel, it still does matter quite a bit. So in your Lca studies, you'll notice that sometimes the aluminum can actually be a fairly significant factor, especially when we're talking about your facades or like curtain wall assemblies, for example. The aluminum that's used in the mullions can actually be really high impact, or aluminum framed windows. So that's, that's just something to consider from an embodied carbon perspective. Glass is, it definitely still has an impact, so it's worth looking at, but it's not necessarily the biggest impact sometimes, even though there's quite a bit of glass that's used. But the framing options can really impact the performance on that front. And one note I'll say is that when it comes to analyzing things relating to the envelope, there is an interaction between operational carbon emissions and embodied carbon emissions. And you need to figure out what the balance is. And as you saw earlier, right, like in Alberta, the trade-off is probably very different than in BC because of the carbon intensity, the operational carbon intensity. So, you don't want to just optimize embodied carbon just for the sake of it and neglect operational carbon, for example. Insulation is another one of those things that we need to do that trade-off analysis in. And in particular, I want to draw your attention to XPS and spray foam insulation, which has fairly large embodied carbon emissions. And it's mainly due to the blowing agents used in these insulations. At least currently right now, soon it'll be phased out due to regulation, but currently they use HFCs, hydrofluorocarbons, which is like refrigerants. So they're like thousands of times more impactful than CO2. So small trace releases of these gases can have a huge climate impact. And so that's why you can see like the emissions, from, I'm showing you across many different types of insulation. So XPS, spray foam, EPS, polyiso, mineral wool, fiberglass, cellulose. So many different types of insulation from R5 to R60 insulation. You can see XPS and spray foam just by the yellow bars, they're very, very high. So that sometimes they're almost like an order of magnitude higher. So it's important to look at the blowing agents in the insulation. But the good news is we are phasing that out. There will be new regulation in Canada next year. So all of Canada will be banning these HFC blowing agents. So there's going to be new products coming online. So that's something to keep an eye out for. And certain US states are also going to introduce HFC regulations, but all the blue states that you see don't have HFC regulations. So some of that original, like the conventional XPS and spray foam is still going to be in the market. Okay, you may have heard of this book called Drawdown, which is looking at what are the key ways of reducing or reversing, or no, I guess reducing global warming or reverse, yeah. I'm tripping over my words, but what are the big strategies, right? So when you think about what's the key solutions to solving climate change, many people will think of things like solar, wind, like those types of technologies that we hear a lot about. But what was really shocking was the number one solution that they had analyzed globally was refrigerant management. Like in terms of what had the greatest potential to reduce emissions, it was refrigerants. Because they have such high impact, like they're thousands of times higher impact, it's just something that I think is a big blind spot for the industry that we need to really look at. And those refrigerants get used in our insulation in the form of blowing agents, but they also get used in our mechanical systems, which I'll speak a bit about soon. So, the number one is refrigerants. Alternative cements, it was number 36. So we talk a lot about concrete and cement, but there are also potentially bigger levers to really look at as well. Not saying we don't address cement, that's definitely still a big problem, but yeah, it's just something to keep in mind. There's also, so for these different refrigerants, you can see like relative to CO2, how many times more impactful they are relative to CO2. So they're in the thousands sometimes, right? And in particular, when we're looking at LCA results or any sort of carbon emission statistic, one thing that most people don't recognize is that because we're trying to evaluate many different greenhouse gases, let's say like methane versus CO2 or HFCs versus CO2, we have to find some way of making it equivalent. And so we have a certain time horizon that we assume. So most statistics, whether it's the IPCC or our national reporting greenhouse gas inventories or your EPDs, they all pretty much all assume 100 years. Why that's important to note is that there's actually these different gases stay in the atmosphere they have different atmospheric lifespans. So for example, you may have heard that methane is 25 or 28 times more impactful than CO2, but that's only over a 100-year time horizon. The reality is that methane's atmospheric lifespan is something like 12 or 14 years. So that doesn't actually stay in the atmosphere for 100 years. So if we actually change the metric to 20 years, GWP 20, it would be 3 times higher. It would be at 84 times more impactful than CO2. So that changes all of our calculus if we actually look at a different time horizon. Same thing with refrigerants, because many of the atmospheric lifespans are under 20 years. Even if you look at the reported emissions compared, which assumes 100 years versus 20-year time horizon, you can see they're typically 2 to 3 times higher. That means any numbers that you see, you almost like inherently, if you just want to get an order of magnitude, multiply by 2 or 3 times. That's the real impact, at least in the short-term horizon. And that matters because if you think about our climate targets and how quickly we need to reduce emissions, it matters when we're reducing those emissions as well. So refrigerant leaks, they can be quite high. I won't get into the details of this, but if you leak a whole system, like your heat pump or your especially variable refrigerant flow systems, which have a lot of refrigerant charge, that can be quite impactful. There's a lot of uncertainty as to what the leakage rates are. So that's an area that we need to explore more. And then there's also, we're not oftentimes looking at the emissions associated with all the MEP systems. So all the ducts, all the pipes, all the air handling units, there's all those materials that go into those mechanical and electrical and plumbing systems. We typically don't quantify that because we don't have good data on it yet. There's some research level studies right now that peg it at, let's say, 40 to 75 kilograms of CO2 per meter squared. Actually, the latest studies that I've seen from Integral Group, they peg it at 50 to 350 kilograms of CO2 per meter squared. So it can be quite high. And then there's the tenant improvements. In this study, they were pegging it 45 to 135. So this is like interiors. So things like cubicles, furniture, flooring, ceilings. And because these things have higher replacement rates, let's say you assume every 15 years you replace it, which is maybe a conservative assumption. You know, some commercial buildings, they probably have tenant improvements that are much more frequent than that. Those, even though the initial embodied carbon of the interiors and the MEP system may be lower compared to the structure, if you factor in that replacement rate, depending on your assumptions on that, they can actually eclipse the total structural impacts over the whole lifespan of, let's say, 60 years. So it's something that we need to look at as well. Yeah, and then I'm just gonna speed through this. So all I'm saying is that, like, relating to embodied carbon, there's many blind spots. You know, embodied carbon itself is a blind spot, and I think there's a lot of room for emissions reduction because we haven't had much attention on this field for a long time. But even within this field, there's blind spots within the blind spots. So, you know, like the insulation impacts, the refrigerants, MEP, interiors, forestry. Those are all areas that we're going to need to explore more, and we may find big opportunities to reduce emissions there. If you want to learn a little bit more, I mean, these are just 2 articles that I wrote for Canadian Architect magazine, which talks about why it's important and how we can reduce it. It's basically a summary of like a lot of the stuff that I presented here. And I oftentimes share a lot of kind of the latest news on embodied carbon on LinkedIn, so feel free to connect with me on there. And yeah, if you have any questions about LCA or want to pursue it on your projects or want to do any any questions on that front, feel free to reach out to me. And here's my contact information. So I want to thank Mehdi and everyone for organizing, everyone from the CLF Alberta team for organizing this. I know we're probably at time right now, but I'll stick around as long as people want to stick around for Q&A. But sorry, that was a pretty information-packed, very fast-paced presentation. But yeah, I'll take any questions.
Thank you very much, Anthony. That was fantastic. I know I learned a lot. I'm definitely one of those people that was thinking / hoping Canada was a little bit more insulated. So that was great facts. Feel free to put some questions in the chat if you want. We'll also probably be, while we have you, if you do have a few more minutes, put some more polls up for you guys, if that's okay. Because as you saw, there was a lot to cover and a lot of times we had to move on, I would say, too quickly. Time was a restriction, but that means we'll be having more events. So we're looking at an event actually in early February about potentially life cycle analysis, and then also looking at future events around environmental product declarations that you heard Anthony talk about. So feel free to put your votes in for what you'd like to hear about next. And we'd love to take that into account for our next events. I think that's it. Other than that, please, is there any other questions? But other than that, please, again, check out the website, sign up for more information. Anthony, of course, mentioned his website and the slides will be available there. But we can make sure, please check the chat link if you want to steal that. Someone put the Dropbox link in there. So, but yeah, other than that, if you have any other questions, please reach out to Anthony or myself or Mehdi or Ignacio, and we can help get you to the right answers. All right, thank you, everyone.
Great. Yeah, and as I said, I'll stick around. So if you want to unmute yourself, if you have any questions, feel free to just unmute yourself, ask a question.
Absolutely. I see someone's looking for the Dropbox link, so maybe I'll just
This is on the chat box. If you need to get to the slide deck, the PDF document, the link provided on the chat box, please.
Yeah, I'll just do it again so everyone has it right at the very bottom. And then, yeah, feel free to go there for the slides.
Mm-hmm.
Not seeing any questions, just tons of great feedback. Thank you, Anthony. Great presentation, very informative, really enjoyed it. So that's fantastic news and feedback. So
I really highly encourage, thank you all for that. And I highly encourage you all to get involved with the CLF Alberta chapter. Like, it all comes together with volunteer effort, right? So if you want to be part of kind of spreading this message in Alberta and kind of building awareness on this front, like, definitely reach out to Kristen, Mehdi, and Ignacio.
Yes, please. We are looking for volunteers. We are a team of 4 and we are looking to expand. So if you have any interest at all and want to help us be part of the education and volunteer for that, that would be fantastic. Please absolutely reach out.
Great. So I see a few questions, so I'll just read them out.
Yeah.
So Christina mentioned was asking about what programs or process are you using to conduct your analysis, Athena, OneClick, others. So personally, we use Athena and OneClick LCA, depending on the scope of the projects. We've actually been doing a bit more OneClick LCA lately. We've been working on a bit more complex projects, especially if they have like Revit models and stuff like that. Yeah, but they're all great tools. They all have different strengths and weaknesses, I would say. But yeah, so that's what we use. And then
Raz had one more. Any idea why refrigerants are more regulated due to their high GHG impacts?
Are more regulated? Well, actually, I don't know that they are. Well, so what was it? In 2016, there's a thing called the Kigali Agreement, which you may have heard of. And that really addressed or was trying to kind of create sort of a global treaty or align all the countries around the world to like develop a kind of a unified strategy to address these impacts of refrigerants and HFCs. So there are some efforts underway on that front. So Canada has a certain plan of like when we're going to phase out various different refrigerants or how to kind of transition to lower global warming potential refrigerants. I think it's very kind of case specific depending on, like, for instance, mechanical equipment. There's many different pieces of mechanical equipment, and for each piece, like they have different, or like let's say certain types of heat pumps or certain refrigerant displays that you use in grocery stores or whatever. Like they all use different refrigerants and have different potential alternatives. And there's a bunch of implications as well. Like, does it meet the flammability requirements and whatnot? So there's a lot to think through on that front. But I think the policymakers are starting to recognize like how important it is, or have recognized it. But it will still take a bit of a time to actually transition away or to find those alternates. And in some cases, there aren't like great alternates, but and in other cases, they already do exist, let's say in Europe or whatnot. Like I think like Daikin's going to be bringing in some like new like mini split systems, I believe, like next year or something like that. So, or with lower embodied global warming potential refrigerants. So it's something to kind of like ask your mechanical engineers on projects about. Yeah. And then
Madeline is asking about low hanging fruit managing carbon impacts with respect to a cooling and heating plant. What would you consider low hanging fruit?
Managing carbon. Well, I mean, actually, I think that's something that I would definitely ask like your mechanical engineers or your energy modelers. That's more in the domain of like operational carbon emissions. If you're talking about like the embodied carbon side, like just the material related aspect, I would say like we don't, that's a fairly new area. Like in our typical LCA studies, we haven't done as much analysis on that front. We're only just starting to get some case studies from, like certain firms like Integral, like we actually recently had an event on LCA of embodied carbon and MEP systems. And so if you want to see those presentations, they're on our CLF Vancouver YouTube channel. So we had a presentation from somebody from UK in the Integral office there. And so they've done some kind of leading edge research on that front. And so that's where they have some of their latest studies on that. But I would say like we are definitely missing data on that front. We don't have a lot of good data from different manufacturers and whatnot. That's on the embodied carbon piece. On the operational side, I mean, I think there's plenty of consultants that can kind of tell you about those strategies, but that's a little bit out of my domain. And let's see, what else is there? Emery is saying, you have an interest in energy efficiency and low carbon emissions. How can you be useful? Well, I mean, with an electrical background, I'm not sure. Well, I mean, I think if you're interested in more of the operational domain, like I said, like you can connect with people that work in that domain, whether it's like energy modelers or mechanical engineers. If you're interested in the embodied side, I mean, I think it is a whole new field in a way. If you think about how much work has been done on the operational carbon side, there's a lot of people that have a lot of expertise and a lot of strategies, a lot of products associated with it. But when it comes to the embodied carbon side, I think there's a lot of room for innovation and and we need people to build up expertise in it rapidly. So I think that is definitely a new area. So that could be some place to just look at, is like, how do you build up your competence on that front?
Asia is asking if there's any pending policies around embodied carbon in Alberta.
Good question. I'm not entirely sure. I haven't heard of anything specifically, but I know at the federal level, the government Canada is definitely looking at this stuff. You know, Infrastructure Canada, the greening government strategy, like there's, they're looking at this. So it may potentially not be at like a whole kind of apply to the whole city level like Vancouver's doing, but I think certain leading clients or kind of institutional investors or different groups, like they may be starting to look at this stuff. So I've definitely seen a lot more interest amongst like very progressive clients or kind of institutions who have kind of developed their own internal mandate on that front. So that might be where you see it first. But then the other piece is I think there's a lot of work to be done to actually build awareness with your clients or with all, you know, all the consultants that you work with on any given project relating to this topic. And I think it's actually an area where you can really differentiate too. It's an area where you can really like stand out and like where your projects can stand out, and also you as a firm can stand out if you develop your competence and expertise in this area, which is fairly new for everyone in the industry.
Anthony, I can add something to that.
Yeah, please do.
You know, in addition to that, on the federal side, there was actually an RFI that was sent out early this year in February, to be exact, about some seeking feedback on low carbon concrete. So that's just another, I guess, message to the industry that the government and government-funded projects in the future will require some kind of compliance requirement as it stands with low carbon concrete. More specifically, the use of PLC cements, the use of EPDs, and setting some thresholds on GWP. So that's an example. And if we see that on the federal side, you know, we probably will tend to see something more on the city or provincial side, like we've seen in Vancouver.
Totally. I'll also mention that there's an initiative that you should all be aware of as well. It's from the National Research Council. They have a whole kind of 4-year initiative that's called Low Carbon Assets Through Life Cycle Assessment. And so the acronym is LCA squared. Very creative. So LCA squared initiative, they're actually really looking at various different elements, all the way from like the background data that we use in LCAs, like what goes into those databases, and is there any gaps, like any key areas where we need to address as a construction industry where we're missing data or where we need to improve data. They're addressing stuff at that level, you know, supporting research and whatnot, all the way to developing guidelines for whole building life cycle assessment for practitioners, and then all the way to, you know, informing like government procurement practices or policies on this direction as well. So yeah, that's just something to kind of have in your radar, is that there's this NRC LCA squared, which is amazing that we've kind of have a federal level initiative that's kind of focusing on this. Was there any other questions?
Yeah, there was one about, have you come across any case studies that have attempted to quantify the savings in offsite and I think on-site modular construction?
That's a good question. I haven't directly. I mean, I would imagine there's potential. Let's see. I mean, I've definitely heard the point made about, you know, like if you're an offsite and it's kind of more like prefab type of stuff, maybe you're reducing the waste that's associated there as well. So there's potentially some savings on that front. And then if you're talking about prefab, like as it relates to, for example, mass timber, like that's a whole different field. And like there's inherent reductions that potentially come from just the use of like a completely different material system as well. But I haven't seen like, yeah, very specific studies on that front. But I think that that's a good topic to dive deeper into.
And then I'm seeing one that's asking about where the diagrams came from. But I'm assuming those links are in the bottom of the
so the Sankey diagram, that Sankey diagram was, and for those of you that don't know what a Sankey diagram, that was like the one that's kind of like the flowy chart, really fancy looking thing, the colorful thing. That one is a graphic that One Click Lca can create. I think I'm not sure if it's available at all tiers of the license or whatever. So that was specific to one project that I worked on. But then I did another layer of like data visualization. Like it doesn't inherently look that nice. So then I kind of use a different program to kind of create that graphic. But the underlying data was generated using Click Lca. And
how important is embodied carbon in Alberta concerning our grid here?
Yeah, it's a good. I mean, I think it's yeah. So on the operational side, obviously, there's a lot of reduction that can be made on the operational piece, right? So I definitely encourage you not to look at things like either or. Like both strategies need to be pursued. It's not like you pursue embodied carbon at the expense of not addressing operational carbon. And oftentimes the conflicts are not as big as you might think it is. Like sometimes people make it out to be a big thing, but it's like sometimes they're different strategies, right? Like, and a lot of strategies on the embodied carbon side, it might actually save you money too, right? If you're actually looking at material efficiency side, if you're talking with your structural engineers, trying to get them to like not over design as much, or you know, maybe you need to work on your column spacing and reduce transfer slabs or stuff like that. There's a lot of things that you can do to actually reduce emissions on that front. It's not just pure material substitutions, like one material is better than another material. There's a lot that can be done on the optimization side of things as well. So it's, I just think it's something that we need to approach on both ends and not make it out to be like sort of competing requirements necessarily. Yeah, so I think they're both important. And
I think that's it for now. It sounds like there's some answers on the modular question in the chat. So I encourage you guys to check that out. Looks like potentially both universities did some studies around that. So some good local information there.
Great. Any other final questions?
Final countdown. Okay. I think that's everything. Yeah. So please just, again, check out our website. We'll keep you posted on our new events. And thank you again so much for attending. It's very, very great to have you with us for our first event. Totally. Yeah. Thanks, everyone. And thanks to all of you for creating this. Yeah, great job on launching this CLF Alberta. And I'm getting such a great turnout. This is amazing. Yeah, I'm very happy. I'm actually from Calgary. I never mentioned this. So I grew up in Calgary. So it warms my heart to see CLF Alberta take off. So good. Right. And one last quick thank you to Anthony. Thank you so much for your time and for your sharing your knowledge with us. So thank you. Totally. All right. Thanks, everyone. Mention everybody that you're going to offer a $20 gift card for everybody who attended. That's why we got such a big crowd. I see. It's a good strategy. All right. Thanks, everyone. Take care. Okay. Cheers.